ASEAN. And for the another biotechnology, because still relatively young, barusan diakreditasi dengan akreditasi sangat baik ya, setingkat menuju unggul ya, because it's, I think make sense karena memang masih sangat muda ya, dan insya Allah dalam waktu dekat ini bisa menjadi unggul. Dan of course untuk magister degree-nya biology sudah unggul lebih duluan di tahun lalu ya, terakreditasi ya Bu Erma ya. So we as a unit or to serving the education, we are in the top level of the system and it's been accredited in the top level. So kita harus maintain semuanya dan seterusnya kita harus terus maintain dengan cara salah satunya adalah memberikan kompetens yang lebih tinggi kepada para mahasiswa kita dengan cara mengundang berbagai expertise dari seluruh negara, seluruh dunia, maaf. Sebelumnya juga ada dari Jerman, dari Australia, juga kemarin ada sempat dari Spain ya, Spanyol, dan dari Jepang, dan dari berbagai negara, dan sehari ini adalah hadir expertise dari USA ya. Anda patut bersyukur ya bahwa kita komit untuk meningkatkan kompetensi mahasiswa melalui berbagai cara. Salah satunya adalah pada hari ini adalah momentum yang sangat penting buat Anda, dan please ask the question ya, jangan shy cat ya, malu-malu kucing ya Bu. Jadi ask the question ya, whatever you like, say in English bisa, Indonesia bisa, Jawa juga bisa, jadi 3 bahasa sudah bisa. Saya kira tidak banyak saya bicara di sini, dan sekali lagi saya ucapkan thank you very much ya for the special guest for today ya, Ibu Siti Nur Hidayati PhD yang berkenan sharing ya informasi dan expertise apapun yang akan disampaikan, cermati dengan baik ya, pelajari, dan jika ada yang ingin ditanyakan, tanyakan. Demikian, billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you Prof. Sabto. Next we will hear a speech from the Dean of the Faculty of Science and Mathematics. We respectfully invite Prof. Dr. Kusworo ADS SCMT to deliver his address.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable Ibu Siti Nur Hidayati PhD, yang terhormat Pak Profesor Sabto, Ketua Departemen Biologi, Prof. Endah, dan segenap dosen di Departemen Biologi. Welcome to my faculty, Faculty of Science and Mathematics, Bu Sri Endah. Jadi kami sangat bahagia sekali Ibu Sri Nur Hidayati bisa rawuh, ini bahasa Jawa rawuh ya, untuk memberikan experience Ibu kepada mahasiswa maupun para dosen, dan ini merupakan program dari World Class University. Jadi kita dari universitas diberi target untuk mengadakan visiting lecturer, studium general, and adjunct professor. So many activity in my faculty. Tentunya ini juga akan memberikan pengalaman baru buat adik-adik mahasiswa yang tentunya akan memberikan tambahan ilmu tidak hanya dari dosen-dosen yang ada di biologi, tapi juga dari dosen di luar biologi, terutama di luar negeri. Ibu Sri Nur, kami mungkin berharap nanti ke depannya bisa menjalin satu kerjasama yang lebih intens. Tentunya kami selalu ada peer untuk penilaian QS World, QS University. Nanti kami, jika nanti Ibu Nur kami pilih untuk sebagai peer, kami mohon kesediaannya untuk memberikan respon terhadap pertanyaan-pertanyaan yang ada di QS Word. Kami sangat berterima kasih sekali jika nantinya ke depan ini juga bukan yang pertama harusnya, dan ke depan harus dilanjutkan lagi dengan kerjasama yang lain. Kemungkinan ada peluang, misalkan jika ada peluang double degree maupun joint degree dengan magister kami, karena di kami ada pendanaan untuk beasiswa double degree maupun joint degree. Nah, kami ada magister biologi yang tentunya nanti bisa dilakukan satu pembicaraan-pembicaraan awal untuk menuju ke double degree. Sekali lagi terima kasih Ibu Sri. Nah, mudah-mudahan dengan Semarang bisa langsung connect dengan makanan. Tadi katanya tahu gimbal, ya itu dekat sini ada Bu Sri. Jadi Pak Supri ada, nanti silahkan Bu Endah sudah mencari Google Map-nya, jadi siap meluncur. Buat adik-adik mahasiswa dan para dosen, manfaatkan momen-momen yang sangat langka ini, tentunya akan menambah pengetahuan, menambah kompetensi buat kita semua. Dan ini bukan berarti wah ini enggak penting, ini sangat penting untuk menambah pengetahuan baru yang tentunya kemungkinan tidak didapatkan pada saat perkuliahan. Jadi silahkan nanti aktif, jangan kata Pak Sabto tadi malu-malu kucing, jadi ya malu bertanya sesat di jalan, ya, tidak bertanya malu-maluin. Jadi mudah-mudahan ini nanti menjadi pengalaman yang sangat berkah. Terima kasih, thank you for your join with us, Ibu Sri, dan terima kasih Prof. Sabto telah mengkoordinir kegiatan ini dengan baik. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, let us now capture this meaningful occasion with a group photo. We kindly invite our speaker, Bu Siti Nur Hidayati, and moderator, Prof. Erma, and all participants to come forward for the photo session. Silakan, mungkin mahasiswa juga bisa meramaikan ya, bisa maju ke depan. Mahasiswa silakan. Kita akan foto menghadap ke belakang karena backgroundnya ada di. Oh sini dulu, boleh. Ayo Mas Hafid dari atas. Baik, terima kasih. Gaya semangat. Undip bermartabat. Undip bermanfaat. Undip Jaya, kepal tangan. Terima kasih, mungkin satu lagi bisa mahasiswa maju ke depan ya. Kita menghadap ke sana karena backgroundnya ada di sini. Silakan mahasiswa bisa ke depan. Mahasiswa ke depan silakan. Mahasiswa bisa di atas, mahasiswa bisa di atas. Ayo mahasiswa bisa mengefektifkan waktu. Di atas dan di pinggir-pinggir masih boleh. Untuk Bapak Ibu dosen mungkin bisa merapat nih. Baik, terima kasih Bapak Ibu bisa kembali. Ladies and gentlemen, we now arrive at the highlight of today's event, a lecture by Mrs. Siti Nur Hidayati, PhD, who will share her expertise and experience on how plants adapt and build resilience in response to increasingly extreme climate change. This session will be guided by our moderator, Prof. Dr. Erma Priyastanti, MSI. We respectfully invite Prof. Erma and Ms. Siti Nur Hidayati, PhD, to begin the session.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Good morning, ladies and gentlemen. Morning. Good morning. Okay. Okay. The Honorable Bunindia as KBK, because Pak Sabto and Pak Dekan leave. The Honorable Ibu Siti Nur Hidayah, PhD, and lecturer from Biology Department, and all of my beloved students. First of all, let us thanks to the Almighty Allah Subhanahu wa Ta'ala. Because of His blessing, we are able to come here to join in this meeting. And the presentation today is about plant regeneration under climate change, plant adaptation and resilience in changing climate. Now I will read one by one our agenda today, that are presentation, start from 9 until 10:30, and then discussion about the question and answer about 1 hour. Before we begin, I would like to introduce the presenter. I will read. Ibu Siti Nur Hidayati from the Department of Biology, Middle Tennessee State University, Murfreesboro, ya Bu, Tennessee, USA. And the education start with the bachelor in the Biologi University Gajah Mada University, and the master program in biology in University of Kentucky, Lexington. Ini kaya apa Bu? Oh, Kentucky. Bukan Kentucky, ayam ya. And PhD in biology too from the University of Kentucky, Lexington. KY. And the position until now, she is a lecturer, Department of Biology, young professor, Natural Science Department, Modlow State Community College, Smyrna. And before, she have words about the influential faculty member Honor Society of Pi Kappa. Ini Filipina ya Bu? Bukan, Philadelphia. Oh, Pi Kappa Pi, MTSU. Oh, okay. And there are many activity for visiting scientists until 2017. And the publication, she have the age index, I see 20, not 19, 20. Oh yeah, age index of her about the 20, in here only 90, and more 52 about his journal in article, book, chapter, and report. And she have worked in invited lecturer from many university in Indonesia. And I think, yeah. Okay. Let's open our meeting by saying Basmalah together. Bismillahirrahmanirrahim. Okay. For the next agenda is presentation. The time is you. Boleh? Silakan Pak Adi, silakan duduk.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I hope you are not falling asleep. And if it's okay, I'd like to walk around. That way you can see me closer. So if, for example, you don't understand my English, you can ask me in Indonesia or even in Japanese. So that's okay. Okay? It is an honor to be here, and thanks for inviting me. Mbak, I'm sorry, I call Mbak Indah and Endang. This is my first time I came to Undip, and hopefully, will not be the last. Okay. This time I will share about my research, my experience in plant regenerations, especially the view or the focus will be on seed. I am a seed ecologist by training. So in maintaining with the new trend, if I just learn about seed, ecologists, it's less meaningful. But now the major problem is the climate change. So this time I will try to connect what happened or what will happen with the plant regeneration in changing climate. So more or less like that. So again, apologize. My English is not like native speaker, even though I live in the US more than 30 years, but my tongue is made in Indonesia. So of course, it will not be the same as the native speaker. So I try though. So sometimes my son also corrected me and said, Mom, your pronunciation should be this and that, when he was young. And then now he will not say anything, whatever I said for that. Okay? Okay, just to give you an idea, where is Tennessee? Where is Middle Tennessee? I know everyone knows about the US. However, the geography may not be in your radar for that. So you know a lot of movies set in Los Angeles, for example. That is in the West Coast. A lot of movies set in New York, for example. That is in the East Coast. So this, no, it doesn't work on that. So the West is in California. Now, luckily, I'm not from there, so I'm safe. I'm from Tennessee, the red state that I highlight over there. So Tennessee is more like a rectangular state. So where is the Middle Tennessee and why the university is called Middle Tennessee? Because where the Murfreesboro located is exactly in the middle of the Tennessee state. So that's why the university is called Middle Tennessee State University. So there is a movement to change the name of the university to just University of Middle Tennessee, but it doesn't fly out for that. So yeah, so that's the campus. The picture in the bottom is actually, that's the library. My office is just next to the library for that. So that's just to give you an idea where Middle Tennessee State is. Okay. So today, I will divide my talk into 3 parts. First, trend in biodiversity change. Of course, every one of you knows what biodiversity is. So I will not talk more about biodiversity. So what is the trend in the biodiversity now? The second part, I will talk about the environmental cues and the climate change on the plant communities. So we have a lot of cues. For example, like this morning, everyone experienced maybe get wet a little bit. So that's part of the environmental cues related to the climate change. What is the effect of that and what's the predictions in the future on the plant regenerations? And then the last but not the least, how might climate change affect the plant regeneration? So after we know the cues, so what will be the effect on the plant regenerations for that? Why we care about biodiversity? Biodiversity gives us a lot. For example, this is provide the foundation for the ecosystem service. If we look at the function of biodiversity, so for example, from the biodiversity, we can harvest material goods, food, all of the food from the biodiversity. It doesn't matter if it is from plant or from the ocean. Okay. That is part of the biodiversity. Housing, timber, door, that is also we harvest from the biodiversity. Medicines, if we look at historical medicine long time ago, people relied on the biodiversity. Just this morning I discussed with Bu Yunita. We're talking about the tolak angin and tolak linu. So where is that from? Biodiversity. fiber, all the clothes that we wear. Where is it from? We harvest it from biodiversity. So biodiversity also underpinning function as a flood control. It's been proven that if we cut most of the trees, the land become bare. Landslide will happen, or in other words, longsor will happen. So biodiversity as a flood control, that is very, very important for that. Another underpinning function is the climate regulations. So when we have a lot of trees, the heat from the sun is being utilized by the plant. That will reduce the amount of the heat that will reach the open surface. So that in return, it will reduce the temperature in the surrounding area. That is as a climate regulation. If we cut down the trees, of course, all the heat will be absorbed by the land surface or water surface. In return, all of those heat that is being absorbed will be reflected back into the atmosphere that increase the temperatures. As a nutrient cycling, when the animal dead, when the tree falls, all of those elements that in the animal, in the plant, it will be cycled through the soil. When the soil, when all the elements being absorbed by the plant, the cycle begin, because when we eat spinach, when we eat the fruit, part of the element also in there, and the cycle begin for that. Bioeconomy. Of course, biodiversity is important as the as a product, as a resources for all the drug. But the newest part now, the pharmaceutical companies start exploring not the land, not the plant, but going deep into the ocean. Use all different type of algae, all different organisms that can be found in the sea, because the plant having a lot more regulation due to the restricted, for example, if they found the component to make the drug, but it just happened that the plant is in the IUCN list, either rare, endangered, threatened, etc. Of course, we cannot explore that. So what is the alternative to find the resources, the same resources that can be used in pharmaceutical? Explore the ocean. The ocean is still open and very wide. And until now, there is less strict regulation to explore the ocean. So the big company love that, because the big company doesn't like the restriction, doesn't like the rules in a way. Another, biofuels. For a long time until now, we depend on the fossil fuel. So what is the alternative to find the resources that can be used to fuel the car, to fuel all the machinery? Biofuel, that is become the alternative. Non-material benefits, we learn a lot from the biodiversity. We learn a lot about the phenomena, what happened in real life from biodiversity. For example, just a simple one. If we cut down the tree, landslide happen, temperature increase. We also use the biodiversity as a recreation area. Taman Nasional, Labuan Bajo, you name it for that. So that's more or less, those are the underpinning function of the biodiversity that support the ecosystem surface for all of us. Not only human beings, but include all of the species in the earth. this is a brief historical perspective. A long time ago, people also used biodiversity. Natural disaster also happened. For example, fire. People used the biodiversity to hunt, to find the food. People also used the biodiversity for a lot of activity, agriculture, forest clearing. Because a long time ago, the population still manageable. The destruction from fire, the destruction from hunting, the destruction from agriculture is not a lot. However, as the world population increased, of course, a lot more people use the biodiversity for hunting. A lot of people need housing. A lot of people need land farming, etc. So that will increase the use that give an effect for long term in the biodiversity. What is the common driver for the biodiversity change? So for example, habitat change. We convert the forest for housing. We convert the open land, the farmland, to build the mall, to build the road, to build the tall road, etc. If all of the building is as needed, as necessary, but we also preserve some of the biodiversity, because whether we like it or not, we need place to live. We need a road to go to from A to B, for example. However, this habitat change lead to over-exploitation. We have one house, but it's not enough for one house. So people have to have 5 houses, for example. That lead to destruction more of the biodiversity. With the opening, with the changing land, with the changing forest into a different function, that will lead to the invasive species enter into the more open area. So when we cut down the trees, for example, so now the sunlight reach the surface even more. Usually, only those species that shade tolerant can grow under the forest. So now with more opening due to the forest being cut, other species also come into those area, occupy those area. So invasive species become more and more occupied those area. So maybe you ask, what's wrong with invasive species? Simple. Because the invasive species become invasive due to the less predator, due to the ability to occupy it in wide range conditions. So that is why it become dominant. When they already established in one place, no predator, originally or biologically, those invasive species already have capability to occupy it in wide range of condition. Of course, it will thrive in the new area. Another driver for the change of the biodiversity, of course, now is climate change and the pollution. The pollution over here is not only the material pollution, but including the gas pollution, human pollution, water pollution, any type of pollution. All of those become the driver of the biodiversity change. Okay. If we talk about the biological activity, all of the biological activity lead to the climate change. The climate change trigger change in the biological activity. So this is intertwined, connected. One aspect triggered another. So these conditions is getting worse if we do not uh, try to reduce the driver that change the biodiversity. So for example, simple, increasing temperatures, just 1 or 1.5 degrees Celsius. That will lead to decreasing Arctic ice. Because the temperature increased, the ice melted. When the ice melted, that means reduce the amount of the heat from the sun that is being reflected back into the atmosphere. With the ice coverage, the heat from the sun is being reflected back into the atmosphere. That reduced the surface temperatures. So now when the ice melt, some of the heat being absorbed by the surface at the night being reflected back into the atmosphere. That increase the surface temperatures, not only in the land, but also in the water, so in the ocean as well. So it is kind of reinforcing increased temperatures, melt the ice, increase the absorption of the heat from the sun, that lead to increased temperature again. So this is kind of, which one is first, the chicken or the egg? In this loss, biodiversity loss, we cannot prevent it, but we can try to slow it down with the alterations. For example, try to prevent the overexploitation. Exploitation is okay, but just don't do the overexploitation, because in this change, a lot more species lost, the range of the biodiversity will save. Not only the range of the biodiversity that change, but that lead to change in the abundance, change in the plant community, also change in the structure in the community. So I will give you an example later for that. When it comes worst to worst, biodiversity change will lead to a lot of extinctions. Maybe now we have a lot of lost genetic diversity because, for example, from the farm aspect, it used to be a farmer can save soybean from the harvest today to be planted next year. However, so now the farmer, the soybean farmer, prefer to have the type of soybean that already has the insecticide injected for it, with the Bt crystal injected to it. What is the purpose? Reduce the use of fertilizer. This is very good because we do not want over-fertilize the land as well. However, this condition created dependency with the big company, not only the big company, but reduce the genetic diversity of the soybean, because it used to be that we can save the best soybean to be planted in the future. But now we cannot do that. As a result, all of the soybean will be in the same genetic variation. That mean in the long term, reduce the genetic diversity as well. Okay, what happened in Indonesia? So this is an example of the plant. What I mean plant over here is the timber. Indonesia has a lot of different type of tree that can be used as a timber. The major family that is being used for timber is Dipterocarpaceae. This is just from the Dipterocarp. A lot of the species is in the endangered or rare. If we look at per island, Kalimantan has the highest number of the endangered plants, followed by Sumatra. It doesn't surprise because Kalimantan is a big island. Sumatra also is a big island. Why Java has a small number of the endangered plant? Because most of the forest in Java has been converted into a different purpose for that. So that's why the number of endangered list in this is small. We also have a good news in terms of the biodiversity, because the improvement in the red list, from all the lists over here, there is an action for habitat protection. Try to reduce the loss of resources, plasma nutfah, that it's already in endangered, critically endangered, or rare for that. With the habitat protections, hopefully, that at least in those particular area, all of those endangered, rare, or critically conditions will be protected. Another improvement from the red list is because reintroduction program. The critically endangered species, we focus how to conserve those plants, how to reintroduce those plants into the area, the natural distribution area. So with this program, some of the species from the red list IUCN being delisted, because now we have a lot of reintroduction that is a success in a way. So no longer being critical or being rare or being endangered for that. Another a bit of good news, prevention of the extinction. This is based on habitat-based protection. So one easy example, how many of you ever heard Rafflesia? How many of you ever seen Rafflesia? No. But at least how many of you ever heard the word Rafflesia flower? Rafflesia is the icon of Indonesia because that's one of the largest flower in the world. Okay? This Rafflesia is very unique because it is parasitic plant. So it doesn't have any leaf, any root, or any stem. But we can see the big flowers in it. Because we still don't know how to propagate the Rafflesia, the easy way to increase or to protect those Rafflesia population is by habitat-based protection. Because this is a parasitic species, now we protect the host plant. Hopefully, if we protect the host plant and then someday the Rafflesia will appear in those host plant. This is an example of the habitat-based protection. The invasive control. As I mentioned before, that invasive species usually is very, very adaptive, meaning it doesn't matter what the condition of the area, it will survive. Another advantage of the invasive species, it doesn't have natural predator. Because it doesn't have natural predator, because they're very adaptive, they become dominant in the area. So if we can control those invasive species, that means also preserve the biodiversity as well. Another a bit of good news is the decreased pressure on the forest. Having more restrictive how to explore, how to open, how to cut down the forest by having legislations. The only problem over here is who is going to police? Who is going to control those? We do have the legislation in place, but controlling or applying those regulation or those legislation, it is still need a lot of work for that. Conservation status. Usually the conservations work on the most dangerous or endangered, and then down to rare. If it's very endangered, critically endangered, and then a lot of conservation effort has been done for that. So another example is using those Rafflesia. Rafflesia, some of them only can be found in a few areas. The largest one, Rafflesia arnoldi, not a problem because it can be found in most of the Sumatra. But the other type of Rafflesia, that very, very, very small habitat, need help to protect those habitat as well, and also to change the status from the endangered into delisted in the under the IUCN for that. Okay. So for the first part, the summary of the first part. Due to the biodiversity loss and the species range safe, we need to be careful about the plant distribution. Okay, species A, for example, durian. We have a lot of native durian species. However, now we got flooded with durian montong, which is not native to Indonesia. If we keep planting the non-native durian, what happened with the native durian? Slowly it will disappear. Slowly will change the range of the safe of the durian habitat. Okay, we know that the climate change is one of the drivers in the biodiversity change. This is actually not just the climate change. Along with the habitat change, overexploitation, invasive, and disease, that will lead to the biodiversity change. As a result, it will change the community structure in the biodiversity. With the success of the conservation, through either protected area, increase the awareness, or the species management. So for example, if the species critically endangered, and then conservation effort toward the management, put the management as a priority for those endangered or critically endangered species. Hopefully that will lead to delisted in the IUCN again for that. Okay, any question? So let's just do informal. If you have any questions, we can stop and then I will answer for that as well. By the way, you can ask me in Indonesian or in Javanese for those of you that speak Javanese, okay? Okay. Now coming to the second part. Environmental cues and the climate change on the plant communities. Okay. How do we have a cloud? Anyone knows? So we know that the warm air rise up, and then the cool air moving down. So what is that anything to do with the cloud? Warm air able to hold a lot of moisture, because the warm air rise up, moving away from the earth's surface, getting cooler and cooler and cooler, lost the capability to hold the moisture. So where does the excess moisture goes? That become a cloud. If the warm air keep rising from the earth's surface or from the water surface, that keep giving excess moisture into the cloud, that's when the rain happens. If in the future the predictions, the temperature increase, the surface temperature, the land temperatures, and also the water surface temperature increase, meaning that they will keep sending a lot of excess moisture to become a cloud and then to become rain for that. It just imagines, during the normal conditions, we just have a small bucket. But with the increasing temperatures, so now we can, or the warm air can hold much more moisture, meaning that the excess moisture toward the rain or toward the cloud is much more. Normal condition, we have a small bucket. Increasing temperatures, we will have larger bucket. If those bucket has a full of water and then tilted, that become rain. Just a simple, right? With the warming in the temperatures, now we have a much larger bucket that will give us more rain to us. However, this phenomena is not all over the place because some place become the drier. Luckily in Indonesia, we already in the tropical country. We already have the equators lined up in Indonesia, meaning that the temperatures warm all the time. The excess moisture that is being sent into the cloud getting more and more and more. So if the temperatures keep increasing, we will have bigger and bigger and bigger bucket. We will have more rain for that. Maybe about 20, 30, 50 years ago, June is already entering the dry season. But how many years now that in June we still have a lot of rain? It used to be April. This is the different meaning of April. April means hujan, April. It's already less rain. May start dry, June, July, August, September, dry season. However, because we have a larger bucket now, we still have a lot of rain in June. It used to be if we have rain in May or in the late April or early June, people always said, oh, this is salah mongso, this is the wrong season. But this phenomena will become normal for us in the future because the prediction with the increasing temperatures, we will have more rain in Indonesia, especially in the west side of Wales line. Okay, how many of you ever heard the word El Nino? We just experienced El Nino a couple years ago, right? So what is El Nino? El Nino or ENSO stands for El Nino Southern Oscillation. Because we have a southern oscillation, we have a northern oscillation, right? So El Nino is a good example of the local event, but it has the global effect. So what does that mean? El Nino started in the South America, so the green over there. During the normal years, the warm temperatures in the South America is being pushed westward toward Australia. Those warm air from the South America carry a lot of moisture. So during the normal years, those moisture is being dumped, converted to rain in the northern Australia and Southeast Asia. So that's normal years. What happened during El Nino? During the El Nino, not enough strong current that pushed the warm air in the South America westward. So those warm air stay in the South America. Because those warm air stays in South America, that will create a lot of rain in the South America that will lead to drought in northern Australia and also Southeast Asia. So that's why during El Nino, a lot of drought happen in Indonesia, but in other part of the world, including the US, some area it become wet. This is what happened. During the normal years, when the strong current pushed the warm air westward, that also stir the ocean. When that strong current move westward, look like a steering the ocean that create the upwelling of the plankton. The plankton that used to be in the bottom, because they steered by the strong current, so now moving up. Those plankton become good sources food for the fish. So during the normal conditions, a lot of fish being harvested in the South America. So now when there is not enough current that will push the warm air westward, that will create the dry in the northern part of Australia and Southeast Asia, in the ocean of the South America, there is no upwelling. So during the El Nino, not enough plankton for the fish to eat. As a result, less fish being harvested in South America during the El Nino. Okay, so now look at the V, that light brown color for that. So during the El Nino, there's not enough strong current that push all the way into northern Australia or Southeast Asia. However, sometimes those current reverse, become a jet stream in those light brown color that will create a lot of moisture toward the America and also toward the South America. So the El Nino that will create the drought in the northern part of Australia and also Southeast Asia, that can also lead to very, very, very wet in North America and also South America. If the jet stream being pushed toward north, that will lead to a lot of rain in the North America. If the jet stream moving south toward east, and then will create a lot of rain in the South America. So that's the El Nino condition. So take home message over here. The El Nino lead to decreased rain in the South Asia and also increased rain in the South America. The El Nino will also reduce the amount of fish being harvested in the South America compared during the regular time or regular year for that. Those two conditions, the El Nino will also lead to a change in the vegetation. So for example, when the drought, it just coincides with the dipterocarp season to produce a flower. Because it's not enough water, not enough humidity, not enough resources to produce the flowers, and that will not produce a flower. This is just one example. So dipterocarp is mass flowering type of plant. When they produce the flower, they produce lots and lots. However, they do not produce flower every year. Some of them, yes, produce flower every year, but most of the dipterocarp that is being harvested to make wood, because it's hardwood, they only produce flower every 2 years, 5 years, 7 years, or 13 years. So, during the El Nino, because the drought that take place in Kalimantan, for example, it just coincides with the season when the dipterocarp produce a flower. That will not happen. That will also lead or influence the vegetation. Not only dipterocarp, but other vegetation as well. I give an example of dipterocarp because the dipterocarp is mass flowering and also very, very, very sensitive to the humidity, because most of the dipterocarp is recalcitrant. Everyone knows what recalcitrant is. That cannot survive without humidity. It's very, very intolerant of the low humidity. So that's the cue, environmental cue, that will affect the biodiversity. Okay, so now what happened in Indonesia? So the climate modeler create two scenarios, 2050 and 2080. With and without the protection or the improvement or the conservation or to reduce the emission. In the 50 and the 80, both models has the same effect in Indonesia. In part of the Indonesia, in the eastern part of Indonesia, the rate of getting dry increase. The drought risk in Indonesia related to El Nino increase in the eastern especially, but in the western part of Indonesia, the intensity of the rain will change. The rain may be more frequent but more intense. Not only more frequent that we will get rain, but it's more intense, meaning that the rain is getting heavier and heavier for that. Both, this is with and without the reduced emission for the 2050 and 2080 is very, very similar. Just the intensity of the rain and the level of the drought that is slightly different between 2050 and 2080 for that. So take home message over here. Indonesia will experience drought more and wet more, depend on which part of Indonesia we're talking about for that. Okay, so now if we talk about plant regenerations, the major driver for plant regenerations, it is two, temperatures and the moisture. It just happened that those two aspects being talked a lot in the climate change conditions. When we talk about the climate change, of course, the temperature change. That lead to change in the plant regenerations. The seed. When the seed fall off the plant, only two outcomes. Landed in the moist area, it will germinate. Landed in the moist area, they cannot germinate because the seed is in the dormant conditions. The way to break the dormancy is by the combination of temperature and the moisture. Either high temperatures or low temperatures. But the moisture also play a very important role in terms of the breaking dormancy as well. When the seed already in the non-dormant conditions, there's no problem. Landing in the moist condition, it will germinate. So the key word over here, temperature and moisture is the major driver for the plant regeneration, whether the seed is non-dormant or dormant. Because to break the dormancy, we can use the combination of the temperature and moisture as well for that. So, okay, let's talk about the general condition of the species. We have a species that very, very broad range. Let me get the water. We also have a species that can only germinate or regenerate in the very narrow conditions. The broad range conditions is called the generalist plant. The very picky, very specific is called the specialist plant. Of course, within the species, there's always individual variation, because in the species, within all of the species, there is a phenotypic plasticity in it that will give the variations individually. So now, within and among the populations, we also have a phenotypic variations. So these variations lead to whether the species can survive in a different condition or not. So this is an example. So the red dome, the red is the specialist. They have a very narrow tolerance. They can only germinate within a certain condition, but this condition is very narrow. The generalist has a much bigger dome, the blue line. So if the resources change, if we look at the bottom picture, bottom left, bottom right for all of you, if the condition change is still within the range, the species can survive. If the condition is already outside of this range, the species cannot survive because the need for the species to regenerate is out of their range for that. So thinking about that, we also assume that the generalist will be more advantage because it has a broad range of conditions that they can tolerate. The specialist is very narrow tolerance for that. However, it's not that simple for that because of the phenotypic variation within species and also among the population as well. Now let's talk about the niche. Niche is the conditions where the species can live, just to make it simple. So we have two different types of niche. Fundamental niche and realized niche. So what's the difference? So I give you two different barnacle over here. The one on the left, the brown barnacles. The fundamental niche is all the way from the high tide all the way to the bottom, to the low tide. Because this species is very tolerant. It's not too sensitive to moisture. If we only know the fundamental niche, so we assume that all of the time the brown barnacle can be found in this range. However, when the other type of barnacle live at the same area, the blue barnacles, because the blue barnacle is very sensitive to moisture, they can only live in the bottom part. So the blue barnacle fundamental niche overlap to the brown barnacle fundamental niche. When they live individually, they can live all the way to this range of the fundamental niche. However, when they have to share the area, because the brown barnacle is not too picky in terms of the moistures, they now being pushed into the upper part of their range. In the second picture, now the brown barnacle, when they only live in the upper portion, they're being pushed to live in the realized niche. Due to the competition, the brown barnacle still can live in the upper part because the upper part is in their range. So from these two types of barnacles, the brown barnacle has broader range or more generalist species. But the blue barnacle, they have a much smaller fundamental niche. When they have to compete with the brown, they push the brown into their realized niche because the blue barnacle is a specialist niche for that. Just to give you an idea what generalist versus the specialist for that. Okay. So now, when we talk about the germinations also has the limit, has the range for every species. What we call it the germination niche breadth for that. So this is based on the resources that used or the environment that being tolerated by individual, population, species, or even clade if you're talking about the phylogenetic aspect. The range for generalists is from the maximum, from the minimum all the way to the maximum. So of course, we have the optimum condition for all the species that can germinate in those. Those range based on the factor levels that will change the structure of the community, because this is just general requirement. Not all species has those same range. If we compare into the specialists will have just a short time in the middle under the optimum. So it's not translated in my slide over here. Specialist has much narrower range for that. Generalist has much bigger range for that. So what happened in the future? This is two scenarios. The current condition and the future conditions. The line is the ambient temperatures where the germination condition being reached for that. So in the top, it has a narrow range, meaning that specialist species. In the bottom, wide range that has generalist species. Right now, the condition where the plant can germinate is still fall within those range. In the future, if the condition for germination fall outside of the range, the narrow species range will have a problem because it's already out of their range to germinate for that. But for the wide range, for the generalist species, not a problem because they still have the condition under their tolerance for that. So what happened in the future? For the narrow range species or the specialist species, if they can adapt into the new conditions that will survive, that may the species still persist. If they cannot adapt into the new conditions, meaning that they can germinate outside of the optimum condition as before, they have to move to the different area. A lot of species creeping up due to these conditions. That used to be we can found in the low elevation, but now we can't because the condition for germination is already moving up outside of the range. For those that can adapt, can migrate, that may also persist. However, for those species that cannot adapt, need what we call it assisted migrations. We plant it into the area where the conditions still in their very narrow range for that. For the wide range species, for the generalist species, it may not be a problem because the conditions, even though it changed, is still within the range. However, these conditions, it may change if we are talking about 4 seasons area. In Indonesia, we only have 2 seasons. It may not be a big deal because those conditions, the temperature is still in their range. But if we are talking about the area where they have 4 seasons, when the temperatures change dramatically between one season to another, that will create a problem even in the generalist species that has very, very wide range of tolerance for that. Okay, get the second part done. Now the last part. How might climate change affect the plant regeneration? So whether we like it, whether we believe it or not, the gradual change is happening. I said whether we like it or whether we believe it or not, because in America, still a lot of people do not believe the global warming, do not believe that the climate change slowly, steadily, gradually change. The reason for those that don't believe climate change is because in the winter we still have a -15, -25 C. This is misconception because the global warming, it is happening all the time and slowly and gradually. It doesn't mean that we are no longer having a snow in the northern part. It doesn't matter that we are not going to have negative temperatures during the winter. That's a misconception that still happens a lot in the US. So a steady gradual change in the climatic variable is happening because slowly the temperature increase. The second, what is the other aspect predicted to increase? Variability of climate. Supposed to be already entering the dry season, but we still have a lot of rain. Supposed to be a wet season, but in some part of the area is too dry. Drought still happen. So the variability of the climate, that also create the unpredictable extreme weather event. Extreme weather event over here, it could be the heat wave. It could be the very, very cold weather, or it could be extremely drought. It could also be a heavy rain, the high intensity of rains, more frequent rains, etc. In part of the serotinous habitat, when the plant is very, very highly flammable, maybe out of control fire happen. So for example, if you heard the fire in California, so California vegetation is dominated by the serotinous which is very flammable. So due to the Mediterranean climate that only hosts those serotinous plants, fire can easily happen in those areas. Another aspect that we have to be aware of, this climate change, it will create a novel climate, especially in the tropical biomes. So for example, remember the small bucket and the large bucket. Because we are in the tropic, that the temperatures relatively high all the time, meaning that send a lot of excess moisture in the cloud that will create rains. So novel climate in the tropical biomes will lead to more intense rains, more frequent rains in part of the area. It may not be all the tropical area, but part of the area, the rain will become more frequent and more intense, meaning the rain is heavier than before that. So that's in the aspect that will create the novel climate, either create drought more or create wet more in those areas. Okay. So now back to the plant regenerations. When the seed being produced, that is also very related to the temperature and humidity. Flowering, no problem. But the maturation to produce seed, the plant experience drought or the plant experience too wet. That will also lead the seed quality. If it's too drought, it may lead to more dormant seed. If it's too wet, it will not be tolerant to the dry conditions. That's one aspect. So now let's look at on the dormancy and the germinations. Only two ways when the seed matures, either non-dormant or dormant. Non-dormant, no problem, because they can germinate anytime. But the dormant seed is the one that become a problem, because to break the dormancy, that's relied to the certain temperatures and also the humidity. Those two combinations will break the dormancy. After the seed become non-dormant, that will also still have a problem, because if the seed already non-dormant, but the area or the habitat become drought due to the effect of El Nino, due to the effect as climate change, that will also not be able to germinate. So temperatures and humidity is very, very important for the plant regeneration. If everything's smooth, we have non-dormant seed, or even the dormant seed already become non-dormant, and then everything is in place, the condition when the seed fall of the plant is already suitable for germination, seedling establishment become no problem. It will not be changed. However, if the dormancy already been broken, but the seed experience not the optimum condition for germinations, the seedling establishment will not happen. That will, in the long term, change the structure of the community. This is part of the slide that I just explained. Seed dispersal, either dormancy occurs or non-dormant seed, and then it will affect the establishment of the plant community as well. Now I give you an example for the specialists on narrow range species and the wide range species. The wide range species usually dispersed by the wind or animal dispersal. The narrow range species, the seed usually dispersed due to the gravity dispersals that will lead to the distribution of the species. The wind and also the animal dispersal, they can disperse further away from the mother plant. So that will create much larger scope, broader scope of the distribution of the species. The narrow species, because the dispersal is due to the gravity, it will just fall close to the area, close to the mother plant. So now what's the implication of those? This is one example of the very narrow species, narrow range species. It is Osmorrhiza. We do have the Osmorrhiza here in Indonesia, but a different species. This species required 1 degree C in order to germinate. If in the future, the area where the natural distribution of the species will not get enough 1 degree C, that means the species is in danger for that. Even the 1 degree is not just 1 or 2 days. It requires a long weeks of cold conditions, up to 12 or 16. This is the implications based on the model from the climate change in the 2050 and the 2080s. The red area is the projected lost habitat. The green area is the projected gain of habitat. Based on just natural conditions without the climate change, this species will lose 2% of habitat if only considered based on the climate conditions. However, in the future, if the temperature keep increasing, if the precipitation keep changing, this species will experience about 48% loss when the habitat and germination is included in the climate models. So this is, we only talk about one species. So in the future, a lot more species will lose the conditions in order to survive for the plant regenerations.
Less than 5 minutes.
5 minutes?
Yes.
Oh, okay. We extend for
Yeah, and then discussion.
Okay. Yeah, try to talk fast now. So now we have a wide dispersal and narrow dispersal. The animal dispersal and wind dispersal is the wide dispersal or wide range species. The narrow range species is using the gravity. So we try to trace all the distributions and then try to plan in the end of those distributions reverse. So for example, in the further north range, we planted into the further south. What happened? That is also to modify what happened in the future with the climate change, with the increasing temperatures. So this is what happened. Species with narrow germination niche predicted to be more sensitive to climate change than those white nets, and we know that because the optimum condition already fall out of this range. However, with the simulated future warming, both the narrow species able to germinate in a different season. So what happens if they germinate in different seasons? Because the wide range temperature now germinate in a different season, in the autumn or in the fall, they will experience winter before they become seedling, or say. As a result, they cannot survive. Yes, they're able to germinate, but they cannot survive due to the temperature conditions after they germinate. So this is another example, plant and animal interactions. Some type of insects, the apple thrips, get the name because this create a lot of damage in the apple plant. These insects, the population oscillate up and down. So, and then the researcher over here tried to connected those up and down populations with the climate, especially the temperature, combination temperature and the humidity. It just matched when the temperature high and the humidity high, the population of apple thrips increase. But when the temperature is normal but the humidity is low, and then the population will be much smaller. Another example over here that very sensitive to temperatures is the bark beetle. This is happen to be in the northern area, that if the insect put the larvae in the pinus tree, this larvae will die if the plant experience the cold weather. With the increasing temperatures, those cold weather is not enough to kill the larvae. As a result, it will kill all the pine tree in this area. Only when the temperature is cold enough to kill the larvae, and then the pine tree will survive for that. Okay, so this is the last one. So what can we learn from that? Even though we only talk about the seed dormancy and the seed germinations, this input of the seed into the community will change the population size and the structure. The change in the temperature and the combination with the humidity will also affect the life cycle of the plant. For example, become desynchronized life cycle effect. I gave you an example of the dipterocarp before. The dipterocarp already produce a flower, and then when the seed maturations drought, that will become desynchronized life cycle for that. And then in the end of the result, it will alter the distribution range of each species. As a result, that will also change the species richness and also species diversity. Okay, on time.
Okay.
Thank you for your attention, and I am ready for any questions.
Okay. Thank you. It's very interesting knowledge and information. So next, this is the time for our discussion, and maybe first I ask for the students for give or want to ask question. So please raise your hand and say your name. Okay. Maybe for the first session, I choose 3 students.
Okay, first I want to say thank you for the opportunity that given to me to ask my question. My name is Harry Fernandez from Biologi bachelor programs. So what I want to ask is how effective are genetical modified crops varieties in improving drought resilience in rain-fed agricultural area of Indonesia? Thank you. Genetically modified crops.
Rekayasa genetika.
Okay, the question is how effective genetically modified crop species in changing climate, right? So we have to keep up with the current conditions. So now from one species, rice, for example. Rice is very important staple for a lot of area. It used to be that the rice always need a lot of water because in the future that some of the area, this is including in the US, will experience less precipitations. They created the genetically modified species of rice or organism or sub of rice that will be tolerant to drought. So it will not need a lot of water. So as it is now, I do not know any other plant, but at least rice has been done for that. If rice has been done for that, it is open for any species to create the species that will be more tolerant to drought. Okay. And actually, the one that lead the research on the rice is my friend, is Indonesian in the US. He's not only create the species of rice that tolerant to drought, but also that has become a hot item now, the rice with the very low glycemic index, because a lot of people that has problem with diabetic, usually the staple food is rice. So by having rice with a very low glycemic index, those people still can eat the rice without worrying about the sugar, the blood sugar level being escalated.
Oke. Pripun bahasa Jawa.
Is that okay?
Oke.
Yeah.
Oke. Next.
Anyone else?
Next.
You can
Okay.
ask me in Indonesian language. Yeah.
Yes.
Mungkin izin pakai bahasa Indonesia aja.
Ya.
Baik, terima kasih atas kesempatannya. Perkenalkan saya Fitri Aprilia Kumala. Izin bertanya, tadi ini kan membahas climate change-nya sangat luar biasa ekstrim gitu ya. Sebenarnya pertanyaannya adalah kira-kira apakah ada suatu cara untuk meningkatkan ketahanan tanaman terhadap cuaca yang ekstrim ini dan juga menjaga kualitas nutrisi dari tanaman hortikultura, karena untuk tanaman hortikultura sendiri itu kan sangat penting untuk kita, terutama untuk nutrisinya sendiri yang di dalamnya itu juga sangat baik untuk kesehatan kita. Itu aja, terima kasih.
Untuk mempertahankan nutrisinya itu biasanya kalau diketahui misalnya jin mana untuk mengontrol nutrisi apa yang mau ditingkatkan, itu bisa dikontrol dengan genetically modified teknik ya. Contohnya gini, di negara-negara Afrika yang staple foodnya adalah beras, itu terjadi banyak defisiensi of vitamin A. Nah, vitamin A ini kan sangat penting. Kalau defisiensi vitamin A sejak kecil, ini akan menyebabkan kebutaan. Nah, salah satu cara untuk memerangi kebutaan ini dengan menyisipkan jin yang bisa memproduksi vitamin A. Ini jinnya itu diambil dari tanaman namanya dafodil. Dafodil ini dalam bunganya itu berwarna kuning. Nah, beta karotin yang sama, yang gene yang sama ada di carrot wortel, itu bisa diambil dari dafodil, disisipkan ke beras, ke padi. Nah, sekarang karena ada sisipan beta karotin, berasnya sekarang bukannya putih tapi kuning karena mengandung vitamin A. Nah, ini untuk memerangi malnutrition and also deficiency of vitamin A. Sekarang tinggal apa yang kita mau. Kalau udah diketahui genomnya, apa gene yang ngontrol, apa gene apa yang mau dimodifikasi, diambil dari mana, itu bisa memungkinkan dengan bioteknologi yang ada sekarang. Salah satu contohnya, ikan salmon. Ikan salmon itu kalau dibiarkan di alam, itu paling cepat bisa dipanen, itu tergantung jenisnya, 3-5 tahun. Karena apa? Karena ikan salmon itu kan hidupnya di daerah 4 musim. Nah, penambahan biomas di ikan salmon itu hanya terjadi pada saat musim panas. Nah, gimana caranya mempercepat pertumbuhan ikan salmon ini? Diambil gene dari atau gen dari ikan yang biasa hidup di Arktik, yang sepanjang hidupnya mengalami suhu rendah. Gennya ini disisipkan ke salmon. Jadi sekarang penumpukan biomas bisa terjadi di setiap saat. Asal salmonnya makan, terjadi penumpukan biomas. Dari yang 3-5 tahun panen, sekarang bisa dipotong setengahnya. Enggak cuman itu, tapi ikannya juga jadi lebih besar. Jadi sekarang dengan genetically modified teknik itu bisa atau memungkinkan apa saja dilakukan. Cukup?
Next. Bu Endang, silakan.
Oke, terima kasih. Bu Nur, saya ingin bertanya, kebanyakan kan tanaman itu bisa berkembang biak dengan biji. Cuman ini yang mau saya tanyakan itu tanaman klonal yang sebagian besar ini dia merupakan tanaman invasif. Nah, ada tanaman klonal yang dia berupa gulma, cenderung invasif. Ada juga tanaman yang klonal tapi bisa dibudidayakan, misalnya stroberi. Ada lagi ini gulma seperti pegagan itu, gulma cuman kecenderungan untuk invasif ini yang perlu dipertanyakan. Nah, yang menjadi pertanyaan saya, bagaimana karakteristik tanaman-tanaman klonal ini yang dia akan tahan pada perubahan iklim saat ini. Kalau dia tahan kan berarti dia punya kecenderungan untuk bersifat invasif. Itu yang ingin saya tanyakan. Terima kasih, Bu Nur.
Terima kasih. Pertama, apakah range distribusi dari spesies tersebut sudah diketahui atau belum? Dari distribusi itu bisa kita lihat apakah ini termasuk tanaman generalis atau spesialis. Bagaimana kondisi optimum bisa berkembang biaknya. Nah, kalau kondisi optimum berkembang biaknya sama distribusinya sudah kita ketahui, kita bisa memprediksi apakah tanaman ini akan menjadi masalah di masa yang akan datang atau enggak. Tapi kalau tanpa mengetahui distribusinya, range distribusinya, akan sulit untuk mengetahui potensial problematik potensialnya di masa yang akan datang. Nah, salah satunya itu. Nah, ini juga sangat Kira-kira begitu ya. Ini saya contohkan, ini menjadi problem sewaktu ada proyek besar membuat seed bank. Idenya bagus sekali. Jadi punya 2 seed bank yang besar. Satu di Svalbard itu di Swedia, tapi lokasinya ada di Arktik, jadi dingin sepanjang masa, tapi di bawah tumpukan es itu dibuat lab untuk nyimpan biji-biji dari seluruh dunia. Nah, kedua, ada seed bank yang dikelola oleh Kew Garden di London. Sama, di Kew Garden ini juga mengoleksi tanaman-tanaman dari seluruh dunia. Nah, sekarang yang jadi problem, jadi masalah atau jadi pertanyaan untuk kedepannya, sewaktu ngoleksi biji-biji tersebut yang sudah dimasukkan ke seed bank, itu ternyata tidak semua itu dari berbagai lokasi distribusi areanya. Ada yang diambil cuman berdasarkan 3 lokasi. Nah, 3 lokasi ini apakah di pinggir, apa di tengah, atau di mananya, nggak jelas. Nah, sedangkan kalau kita lihat salah satu slide saya, berdasarkan perakiraan atau climate model di masa yang akan datang, kombinasi antara climate change sama habitat loss atau phenotypic plasticity tanaman itu sendiri mengkerut. Nah, kalau misalnya biji dikoleksi di area di paling pinggir distribusi, terus kita tes 50 tahun yang akan datang. Nah, ini akan jadi masalah karena kemungkinan besarnya yang di pinggir distribusi ini sudah enggak ada tanamannya. Padahal banyak juga tanaman-tanaman yang masuk ke seed bank itu belum dites bagaimana cara memecahkan dormansinya. Banyak sekali biaya yang sudah dikeluarkan tapi masalah dasarnya tidak diperhitungkan. Nah, ini kira-kiranya sama-sama dengan gulma tadi. Kita perlu melihat range distribusinya. Yang paling luar itu di mana, yang paling tengahnya itu di mana, di luar kiri, kanan, muka, belakang itu di mana ya. Karena untuk mengetahui potensi apakah akan jadi problem atau enggak, itu kalau misalnya yang di luar, distribusi paling luar, dengan kenaikan temperatur 0,5 derajat aja sudah tidak bisa bertahan, ini enggak akan jadi masalah. Tapi kalau yang distribusi udara paling luar, ini tetap tambah melebar, tambah keluar kemana-mana, nah itu kemungkinan besarnya jadi potensi di masa yang akan datang. Kira-kiranya begitu.
Bagaimana Bu Endang? Okay, maybe 2 question again. Ya, silakan.
Sebelumnya terima kasih atas kesempatannya Ibu Siti. Perkenalkan, nama saya Adriano. Di sini saya mau izin bertanya, tetapi agak sedikit menyinggung konteks mikrobiologis. Jadi dalam permasalahan climate change itu kan bukan hanya mempengaruhi adaptasi dari suatu tumbuhan, tapi juga struktur konsorsium atau komunitas mikroorganisme di dalam tumbuhan tersebut. Sebagai contohnya saya mau bertanya, bagaimana climate change ini mempengaruhi sebuah konsorsium yang awalnya itu bersifat jamur endofit yang menguntungkan tanaman tersebut. Tetapi akibat dari climate change ini berubah menjadi patogen oportunistik. Mengapa hal itu bisa terjadi? Terima kasih.
Ini saya contohkan bukan dari mikronya ya. Salah satu contohnya adalah lichen. Lichen, ada yang tahu lichen? Lichen itu kombinasi antara apa?
Lumut,
Jamur dan algae. Nah, selama ini kita kan selalu menganggap bahwa lichen itu symbiotic mutualism. Artinya saling menguntungkan. Ternyata enggak semua lichen itu mutualism. Karena ada beberapa jenis lichen yang ternyata salah satunya itu amat sangat dirugikan, walaupun tidak sampai mematikan. Nah ini diperkirakan terjadi perubahan itu karena sehubungan dengan climate change dan sehubungan dengan mungkin ada mikroorganisme yang mendukung untuk terjadinya parasitisme tersebut. Nah, selama ini kita selalu menganggap oh itu mutualism. Tapi ternyata setelah diteliti lebih lanjut ada juga yang dalam bentuk parasitisme cuman tidak sampai mematikan. Nah, ini kalau bisa terjadi di lichen, ada kemungkinan terjadi di lain spesies juga. Kira-kira begitu. Sudah?
Baik, terima kasih Ibu.
Oke, silakan. Yang Mas depan, sebutkan namanya.
Baik, terima kasih Ibu atas kesempatannya. Saya Kudin. Mungkin pertanyaan saya lebih ke arah teknologinya ya Ibu. Nah, seiring dengan perubahan iklim di Indonesia, contohnya adalah bulan ini seharusnya musim kemarau. Kita lihat bahwasanya di luar sana masih terjadi hujan, bahkan di beberapa wilayah di Indonesia itu masih ada banjir dan lain-lain seperti itu. Nah, kira-kira sistem monitoring atau pemantauan dan analisis data seperti apa yang lebih tepat untuk pertumbuhan dan produksi tanaman, terutama dengan seiring berubahnya iklim seperti itu. Nah, seperti saya ketahui bahwasanya mungkin salah satu yang pernah saya ajukan adalah tentang AI, Artificial Intelligence. Nah, itu lebih tepatnya adalah Internet of Things seperti itu. Nah, itu mungkin menjadi salah satu teknologi yang bisa menjadi monitoring system. Nah, menurut Ibu sendiri kira-kira yang lebih tepat selain AI atau IoT, kira-kira seperti apa seperti itu? Terima kasih.
Saya kira dengan sistem AI itu udah sangat bagus ya. Cuman sekarang masalahnya belum banyak petani atau farmer itu yang menghubungkan itu dengan AI. Kalau di Amerika sekarang ada yang namanya smart farming. Nah, smart farming ini setiap farmer di sana mempunyai perangkat untuk mengikuti ramalan cuaca. Jadi ramalan cuacanya ada jangka berapa lama gitu. Ini karena sangat membantu pada saat musim panen, misalnya musim panen kapas. Nah, 3 hari mendatang mau hujan, harus dipanen sekarang. Salah satu contohnya, panen kedelai, ini mau hujan, ini harus segera dipanen. Atau karena ini hujan, oh nanti 5 hari mendatang akan terang, jadi bisa dipanen, ditunda gitu. Nah, sekarang yang perlu dilakukan adalah mensosialisasikan AI yang dihubungkan dengan farmer. Karena kalau misalnya dari orang-orang yang berkecimpung dengan teknologi tidak menghubungkan penemuannya dengan praktisi, ini akan sia-sia penemuannya. Nah, kalau di Amerika itu yang dinamakan smart farmer itu, jadi masing-masing itu sudah mempunyai perangkat yang dikaitkan dengan ramalan cuaca. Mungkin dengan adanya AI bisa semakin tambah maju untuk memprediksi masa kedepannya gitu. Bisa?
Ada lagi? Karena waktunya terbatas, satu lagi Bu dari saya. Ya, karena ini ilmu yang Ibu berikan itu beberapa memang kami ada di RPS untuk materi ini, tapi mungkin saya ingin bertanya biar nanti mahasiswa tidak penasaran tentang novel climate. If I searching in the internet, this is in Indonesia, novel climate merujuk pada kondisi iklim baru yang muncul akibat perubahan iklim yang tidak memiliki analog dalam catatan iklim masa lalu. So I will ask you about the today from BMKG Indonesia said that 2 days is extreme for the rainy day. So this is the period for dry season. So if is this example for the novel climates, maybe? Okay,
It is
thank you.
part of the what they call it novel climate is kind of unusual pattern that we do not have it before. So become novel because we have not have long record. For example, June having a heavy rain.
Yes.
So far, slight rain is okay, but heavy rain in June, that is the novel. So that is part of the unpredictable effect of the climate change that will create the novel climate, especially in the tropical. Maybe some other area experience very, very dry at the same time. So either the extreme dry, extreme wet, or unusual unusual condition that we experience that they never experienced before.
Okay. Thank you. Jelas ya. Jadi mungkin hari ini ada tambahan tentang novel climate. Ya, jadi mungkin seperti hari ini atau mungkin yang tidak bisa diprediksi itu bisa menjadi salah satu contoh dari novel climate. Ya. Because time is limited, very limited, and I think it's finished for discussion session. So
terima kasih untuk adik-adik, untuk para dosen, para pembimbing semua perhatiannya. Semoga ada satu atau dua hal yang bisa dipelajari dari apa yang saya sampaikan. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, from this event, maybe I will read about the conclusion. Okay, for this lecture, we have a conclusion about the climate change significantly affects plant biodiversity, community structure, and regeneration process, while some species may adapt through phenotypic plasticity or wideness, breadth, many other, especially those with narrow ecological range or specialist germination requirement are highly vulnerable. This is conclusion for our, and I would like to say thanks you to all, especially for Ibu Nur, for the great presentation today, and to the audience for their activity participants. Thank you for your attention and have a great day. Hopefully, the presentation will give benefit for us, and see you later.
Thank you, Prof. Erma and Mrs. Nur Hidayati, PhD, for the engaging and insightful presentation and discussion. Dear guests, following today's enlightening presentation, we now move to one of the most important moments of the event, the signing letter of appointment, or LOA, between Mrs. Siti Nur Hidayati, PhD, and Dean of the Faculty of Science and Mathematics, mungkin juga bisa disaksikan nanti dengan Prof. Endah dan Bu Ketua KPK, Bu Nintia, untuk menyaksikan penandatanganan LOA. Saya persilahkan maju ke depan. Monggo. Mungkin bisa dilanjutkan foto bersama, Bu. Mas Haikal bisa dibantu foto bersama. Kami umumkan untuk mahasiswa setelah ini bisa menandatangani presensi untuk penilaian partisipatif ya. Jadi nanti setelah ini bisa ke depan ya untuk tanda tangan penilaian presensi. Mungkin itu saja, terima kasih atas perhatian dari mahasiswa dan juga Bapak Ibu dosen. Saya selaku pembawa acara mohon maaf bila ada banyak kekeliruan, salah kata. Saya akhiri, wassalamualaikum warahmatullahi wabarakatuh.